My name is Lieutenant Colonel Michael Kroll, and what I'm going to be presenting on today is the Digital Dentist, lighter, faster, and further forward. This entire presentation came together based off of my recent experiences as the Forward Dental Company Area Support Commander in the CENTCOM area of operations. My day job is at the Presidio of Monterey, or our Language Institute in Monterey, California. Just to test everybody's digital prowess in this room, feel free to pull out your smartphone, open your camera app, and take a picture of this QR code. It'll link you into a Google search for the Presidio of Monterey Dental Clinic. It also will link you to the first couple links should be the articles that we've published on digital dentistry, and it should give you an idea for how beautiful of an assignment this truly is in the Army Dental Corps. So you can imagine the look on my face when I heard that I was going to be going to the middle of the desert for a little over 9 months and potentially not having any sort of digital dentistry. I was very surprised, and this is our story about how we were able to bring digital dentistry to the warfighter in a combat zone. So here's my disclaimer. These are the official views, or these are not the official views of the United States government. These are my own personal opinions, and I do not have any financial interest in any of the companies or products or materials that I discuss in this presentation. So everyone who's familiar with a deployment environment is familiar with what this screen is, and this is a picture of my container that contained all of my dental supplies. So let me bring you inside my dental container and talk to you about why our dental company area support adopted a lighter digital workflow, how we went through and innovated dentistry within the CENTCOM area of operations, and what is the way forward to make sure that we incorporate this and modernize our force. So just to bring you into what I did on a daily basis, it wasn't all crowns and beautiful dental work. But what we saw a lot of were these mundane type of cases, right? My face is swollen. My tooth hurts. I got hit in the face, or I broke a tooth. And when we first got to CENTCOM, there was no way that we could actually record how often these things were occurring or what mechanisms of injury we were seeing. So in order for us to be able to apply the appropriate work or effort to a problem, we have to first quantify that problem and know how often are these different types of procedures actually coming to our doorstep. And then on top of that, how often are these types of procedures coming to my doorstep, right? These complex prosthodontic issues, right? So what happens when these injuries occur further forward, and how often does this happen, right? This would need something called comprehensive dental care. And in the realm of operational dental care, we first have to look and see what types of definitions we use to determine what level of dental care this patient needs. So when we go through and we're quantifying all these things, we had to create our own methods to ensure we applied the proper type of support and the proper type of attention to these different dental injuries. So we went ahead and simply created a Microsoft form, and we recorded 679 patient encounters over a period of 270 days. Well, the reason we created this form was our old form that we had was very, very long and cumbersome and had a very low compliance rate with people filling it out. This form took about 45 seconds for my providers to fill out, and we had a 95% compliance rate with the amount of sick call encounters we were able to capture. We collected this immediately after the procedure when we were entering the notes, and we broke this down in some simple categories, what we call our Class 8 medical supply categories. So that way I can know how much supply do I need to spend on dental emergencies for restorative, for oral surgery, for endodontics, and for complex prosthodontics. So we broke it down in some basic categories, and this is kind of what we saw. So what we saw in deployment was what a lot of people have seen throughout the literature. The primary mechanism of injuries that we saw were basically restorative driven, whether it was traumatic, meaning that it happened during combat operations, or it happened during a training event, or it was just an old restoration that broke. Then we saw about 20% were oral surgery, endodontics or root canals are about 12%, and prosthodontics were about 10%, right? So when we look here at temporomandibular joint disorder and prosthodontics, that's 15%. A little bit greater than my endodontic treatment need was currently unmet in certain areas throughout theater. So how can we apply the proper amount of dental care to these patients to make sure they're treated no matter where they're at? So to understand how the U.S. Army looks at dental care, we have to understand what documentation we use. So to define operational dental care, we break it down into 3 different categories. We break it down into what's called emergency dental care, typically what we would see at the roll 1, or what you see here in my tent that I've set up kind of on its own. It's very small, very austere, very Spartan. And what we tend to find is that this is really life, limb, or eyesight type of treatment. This is to control life-threatening oral conditions, trauma to teeth, and associated facial structures. Generally, we don't have to bring a lot of equipment with us, and this can occur at the point of injury. Essential dental care is typically what we spend a lot of time on through our dental company area support, and this is one of our highest categories of operational dental care. This is everything to intercept potential dental emergencies and prevent lost time and preserve the fighting strength. This is directly out of what's called our ATP 4.02-19. But we also have comprehensive dental care. This is usually reserved to our higher echelons of care. We can consider this to happen at Roll 2 or Roll 3 types of facilities, but due to the complexity of the procedures, this usually requires patients to be held for a little bit longer period of time. So for that 15% of patients, how can we take this dental care and bring it further forward? So here's our problem that we faced, right? Our current deployed dental sets are heavy, especially when we look at prosthodontic dental sets. They can weigh upwards of 1,300 pounds or 600 kilograms. And they have many parts, right? So these parts can be over 350 individual parts in order for us to deliver something as simple as a temporary denture or an Essex style or clear style retainer that maybe has a false tooth in it. It takes a lot of parts and pieces to make these individual devices. In multi-domain combat operations or large-scale combat operations where we may have to move our higher echelons of care rapidly, this could create a problem. And a lot of our equipment is too heavy and too large to be moved by organic vehicles. So we thought, how can digital dentistry or CAD/CAM systems help us with this problem? So here's what we did. We decided to bring some innovative equipment along with some newer devices to deliver more emergent style dental care, pair them together to see how far forward we could take comprehensive dental services. So we were the first to bring operational CAD/CAM systems into theater to include digital scanners, CAD software, and additive manufacturing combined as a total CAD/CAM system. We were also the first to bring lighter forward treatment equipment, the modular plastic dental chair, the field portable dental system, also combined with pressure pot sterilization to give us robust services even in environments that didn't necessarily have things that we could fall in on. And overall, our mission was to be lighter, faster, and further forward. Now, when we think about CAD/CAM systems, we have to ask, is it ready to be a replacement for conventional produced dental products? And in a recent systematic review in the Journal of Biomaterials, we found that CAD/CAM materials do present a wide range of clinical applications, and they can be a replacement for our conventional products based on their improved mechanical properties. So when we look at our highest levels of dental evidence, CAD/CAM systems and CAD/CAM produced products are definitely there and ready to replace or surpass many of our conventional products. So when we look at CAD/CAM systems, we have to take a systems approach. We have to define every step of our process in order to be lighter, faster, and further forward. So what does this mean? We have to have a way to capture our image. That's typically something in the range of just an intraoral scanner, which is laptop-based. The nice thing about laptop-based scanners, they often have the computer-aided design components right in the same type of computer. So those go back and forth. They go hand in hand to have capture in CAD. Now, computer-aided manufacturing, we usually see that as being pretty cumbersome, right? In subtractive manufacturing or using mills to make or fabricate restorations. Additive manufacturing is very cheap, it's light, it's responsive, and this is where dentistry is going. We're looking at being able to 3D print definitive products in the very near future, which can have a wide range of dental applications. So when we think about all that, we also have to have connectivity, right? So if we're in large scale combat operations, connectivity, if let's say the network goes down due to electronic warfare, we can still have computers plugged into each other that allows those computers to communicate very easily, right? But if we do have internet connectivity and we do have cloud-based systems, we can actually send these things back to stateside and have real-time communication with specialists that maybe aren't deployed. This is a win for our patient. But ultimately, we have to have all of this under a centralized type of sustainment agreement. We have to understand that this system has to be sustainable and trainable to use in the future. So these systems can be delivered at the roll 1 in terms of just a dental scanner at the point of injury, roll 2 in additive manufacturing due to its decreased weight, and then subtractive manufacturing at a roll 3 style of level. So what did we do to be lighter? Well, we put together kind of a prototype kit that we could make a dental laboratory that we could carry around theater with us to deliver comprehensive dental services and augment the warfighter. So we used a 3D printer, a scanner, a laptop, a curing light, some post-processing materials, and we put all of this to create crowns, dentures, models, and splints into a hard-sided case that weighed about 70 pounds or 31 kilograms. And this allowed us to go forward to places. This is an Air Force patient at a Roll 1 Air Force clinic that broke a front tooth. And instead of sending the patient back to us, we went to the patient with all of our gear, and we were able to do the non-surgical root canal therapy, rebuild the tooth, and deliver a nice restoration to the patient in a very timely fashion, right? This is a very simple example of how this can work, but it really drives the point home that this technology is ready to be deployed. The other thing that we have to look at is space. How much space does this equipment use? Well, depending on where we travel, and if it comes to travel, trying to transport ammunition or more troops or my dental equipment, which one's going to win? It's going to be the war fighter. It's going to be the bullets to keep the war going. My dental equipment isn't really going to be that important. So how can I make more capable equipment smaller, right? All of our dental laboratory equipment fit into about 7 cubic feet. As a reference, the back of a sport utility vehicle or a standard Toyota 4Runner is about 25 to 27 cubic feet, right? So when we look at that, it occupies a very small space. We can also carry it on our back of 2 people along with our portable field dental system to be able to carry it by land or air. We also say sea because the United States Navy does use this type of digital equipment on its aircraft carriers. So again, we know that not only are we saving space and weight, but it can be deployed in multiple different environments. The other thing that we know is our 3D printed denture bases were superior to injection molded or packed bases in terms of flexural strength. This comes from our award-winning graduate dental education program at Fort Hood, Texas, or Fort Cavazos, as it's been renamed. And this is by Major Passy, who just actually won one of our research awards for this wonderful research design. And what it showed is that 3D printed dental materials not only can be lighter, faster, more adaptable, but also can be superior to their conventionally produced counterparts. So what were we bringing? We used, from a 3D printer, a light-emitting diode type of printer. Standard is about 405 nanometers is the wavelength that it uses, and it looks about the size of a cell phone screen. They're generally pretty small. They're throwaway. They're about $500 printers, and they can use a monochromatic LED light to produce a narrow band of UV light that cures dental resin. Okay, the one we used was a 4K resolution, much like your 4K screens on your smartphones. Very similar to that. So how does this work and what does it look like? Well, here's a short video I made of the additive manufacturing process. This 3D printer only consumes about 70 watts, and so it can run about 13 hours on a 500 watt portable power supply. So when I think of how long should something work in the mouth, or how long should something work in an austere environment, I look at an 8-hour period. As you can see, this laser light, or this LED light, is curing this resin vat, and it's just moving up and curing one layer at a time. So obviously this is time-lapsed and sped up to show you the process, but there's our printed 3D product. Next, it goes through what's called an isopropyl alcohol bath, which is a very easy product to get all throughout theater. And then it goes through a final curing process. Here we have it curing in a glycerin solution, but you can just go ahead and also cure it by putting it in the light source. Now, per the manufacturer's instructions for use, there are certain curing times, and this is generally the longest part of the process to get our final printed device in theater. So, how else are we faster, right? That's a pretty fast process to make a 3D printed device. But does digital dentistry save time, and does it impact the warfighter? Well, first, we have to look at lead time, right? So the amount of time that soldier is with us and its impact on dental readiness, and shortening the process makes the patient have fewer emergency dental visits and less time in our dental chair. So we also want to show the increased market share, right? So when we look at that, how do we look at the increased market share, and how can we place that on the cost avoidance value of digital technology? What do I mean by cost avoidance? I mean, if we're using a scanner instead of taking a print, or instead of taking an impression, that impression is going to actually have some sort of direct cost associated to it to actually fabricate a dental model. If we take a scan, we have a one-time cost. So we can actually look at a direct cost avoidance calculation by avoiding taking impressions. So how can we look at this? Well, I went ahead and, as the CAD/CAM consultant for Colonel Tanner, we pulled a bunch of data from military dental health records from 2017 until 2022, and we used SAS programming to generate line item level data. So we created these unique patient encounters looking at dental coding methodology. And what we wanted to find out is, what is faster for our patients, conventional or digital dentistry? So which one is faster? So just looking at one encounter, or one type of encounter, just looking at a crown. Over 35,000 patient encounters resulted in 70% of CAD/CAM crowns being completed in a single visit, meaning the patient left in a readiness state one time in my dental chair. When I looked at things conventionally, over 22,000 patient encounters, what we found is the average lead time, or the time from start prepping the tooth to completion, was 31 days. So that is a tangible thing that I used to take forward to my commanders and say, this technology is going to get your soldiers back to you faster, and this is why I need the money for this type of device, because it's going to save you time, and we have data to prove that. So what about being so fast as to fixing this in a 3-hour period of time? I'm going to go back to my chief of staff, who has this broken front tooth, or as he called it, his loose veneer, before he went further forward. How can we fix this? So first, we take a digital scan of his mouth and create a basic CAD design. We use this as our digital diagnostic wax-up. I prepare his teeth, do interim pulpal therapy, do some buildups, and then we 3D print out of a biocompatible resin a provisional material that he can leave and go further forward on his mission. I then take that digital design, send it to our Navy Dental Laboratory, who fabricates this out of zirconia on a 5-axis milling machine. And utilizing supply chains, they're able to send me a final product back in less than a week. And in-house, I'm able to 3D print a night guard for this patient. I'm happy to announce that this patient still has this device in his mouth 1 year later, has no issues with it, and just had his dental checkup and is very happy with our digital design and what he was able to get in theater. So these are things that are very possible for us even in a deployed setting. Well, what about when we want to go further forward to a role 2, right? Luckily for my chief of staff, all of that happened at a role 3. This is a patient that had a training accident and had a fixed dental prosthetic that fell out due to getting hit in the face while on a joint training exercise. So my dental team was very happy to get out on a Blackhawk and go to this role 2 that didn't have the capability in order to maybe 3D print or make these type of devices in-house. And we were able to get that bridge into the patient's mouth the same day. So overall, this patient was very happy, and we were able to bring our products to them in a very fast and timely fashion, right? So if they had 3D printing at the role 2, we wouldn't have had to travel, but we were happy to bring our equipment further forward. So what did we bring? So when we hop onto a Blackhawk, we want to bring something that's very light. So with us, we are the first in theater to bring the Expeditionary Field Dental System, or we call it the Field Portable Dental System. And this is a lightweight battery-powered electric handpiece made by Aseptico that weighs under 30 pounds when in the backpack configuration. It also has a battery power and solar rechargeable status, and it gives us about 8 hours of dentistry out of this little battery powered unit. It's a very capable unit. We've used it from everything from prepping teeth for crown and bridge to doing surgical extractions. So a very, very capable device. The other thing we brought with us to the point of injury was our digital scanner, right? So this is an innovative piece of equipment that is super easy to take to a point of injury if there's no bullets flying at you, right? If bullets are flying at you in a large-scale combat operation, this absolutely still could be with that dentist that's further forward, just plugged into his regular dental computer, and he could go ahead and extract a tooth and scan the patient and have the process of the replacement tooth being made once the conflict cools down in that area and we can evacuate that patient. Now, we're able to do this because of its small footprint and its small size. This Prime Scan Connect unit is very streamlined and is so accurate that it can replace most of our traditional impressions and simplify our workflow processes. This is about 71 watt hours of power draw, and so we can run this for about 7 hours on that 500 watt portable power station. And for anyone who's unfamiliar, those are generally the size of a small cooler, and those are solar rechargeable. So when you think about it, the amount of power that's required is very, very minimal for these products. So what did this allow us to do? This allowed us to get into theater and project into places that other dental companies didn't get a chance to go. You can see the small footprint of equipment that we have piled up over here that allowed us to get into role 1 types of environments. So there's a cardiac patient being seen for an actual trauma that's happening behind us, and my team is plugging away off in the corner, not in the way of their trauma bay at all. So it allows us to be more productive and have more frequent forward missions. So overall, what type of forward services did we provide? So this is me explaining the digital process to some of our general officers. This is Major General Marsiglia. And I was explaining to him some of the advantages to what we brought into theater with just about $30,000 in technology. We saved a direct cost of about $1,148 in skipping taking alginate impressions. And this is including all of the cost of my resin and everything that's included. This is a big cost savings, right? We don't have to take these conventional impressions. Our digitally assisted final restorations we were able to deliver were about $230,000. And we were able to bring forward $51,000 in occlusal devices for people that grind their teeth, custom athletic mouth guards for people that broke teeth and we replaced them and now we want to protect that patient, and about $50,000 in sleep devices to help patients that are snoring in open bays. So overall, combining what all of my colleagues have done, we brought this CAD/CAM system in for about $350,000 of production over a 9-month period. This is awesome because now I can say For $30,000 of equipment, we have a return on our investment of $352,000 in production. This was a positive return to the taxpayer, and something that's not just a cool project, but something we should look into in more forward planning on future missions and operations. So what's the way forward? The way forward with 3D printing and additive manufacturing is for dentistry to lead the way. We can use digital scanning and 3D printing to augment supply chain deficiencies and help with part fabrication on the battlefield. Here's a very simple example where at one of our Roll 3 clinics, we ran out of amalgam traps. We had a funding issue at the end of the fiscal year. So I had the doctor scan it with their intraoral scanner. I then put this into my design software, created some holes, and printed a bunch of amalgam traps so that way we could keep them going until we were able to actually get amalgam traps through our supply chain system. CAD/CAM systems can be scaled from the dentist at the point of injury to the hospital and back at our home station. So looking at that CAD/CAM system and truly identifying where does this fit into large-scale combat operations and how do we modernize our dental sets. We then want to look and see how can we leverage cloud-based systems to enable our global network to make sure that we have a care web for that patient from the point of injury and vertical integration all the way back to their home station, and lean on our electronic health records and laboratory support so we don't have to bring as much equipment into theater and we can move faster in response to large-scale combat. Now, modernization needs to occur and it needs to be sustained through our graduate education in the Army Dental Corps. And it's the next generation providers that are going to take these topics and move them even further forward. So in conclusion, this is our happy patient that had that broken anterior bridge that Major Mooney and I fixed. And hopefully you can see why the dental company area support adopted a digital workflow, how our dental company area support forward innovated dentistry in the CENTCOM area of operations, and what the way forward is to make sure that this just isn't a flash in the pan, and this is something that we can carry on and sustain for future generations. Now, I'm a big believer in finding your passion. My passion, and I've been super lucky in the Army to be able to do this, is to teach young dentists throughout the Army, Navy, and Air Force dental corps on how to deliver digital dentistry to our patients. I've made that my purpose over my Army dental career, and I just recently, right before I came here, was actually gone for a week teaching at a dental residency in Fort Campbell, Kentucky, and this was super great. You know, whenever I think about getting to train these young dental officers, I always think about, you know, what their future is going to be like in the Army Dental Corps. And as I'm standing here and I'm teaching them how to mill on some of our state-of-the-art milling equipment and stain and glaze our crowns, I look up to look at some of the past graduates of this exact same dental residency program. And who do I see on the board but a young Captain Tanner, the leader of this organization right here, was also trained at Fort Campbell. So when I think about that, my passion is truly to pass on my love of digital dentistry to the younger generations, show them the operational relevance, and hope that they can modernize things in 2035, 2040, and forward to help in conflicts that I can't even begin to comprehend. Without further ado, though, I want to open up to any questions, and I really thank you all for your time and listening to our story about how we brought digital dentistry to the warfighter in the CENTCOM area of operations. Thank you so much.